Welcome to this video course on Minimal API with .NET 7. By the end of the course, you will be able to build well-constructed Minimal API Endpoints. Brugam Patel developed this course. He is an experienced and popular course creator and developer. Let's get started.
Hi guys, and welcome to .NET Mastery. My name is Brugam and I will be your instructor for this course on Minimal API. API has been there since a very long time, but Microsoft has launched something new with API, which are Minimal API. If you are a .NET developer, your first reaction would be, why would I need Minimal API when I'm perfectly happy with the standard API that are there? On top of that, Minimal API, as the name suggests, offer less features as compared to a traditional API. And in this course, we will answer all of those questions as we will explore all the benefits Minimal API brings to the table. We have a lot to cover in this course, but there are some prerequisites that you should know. So you should be able to follow along as long as you have about 3 to 6 months of experience with C#. That being said, let me walk you through on what we will cover in this course and explore the new world of Minimal API. Let's take a look at what will be all the topics that will be covered in this course. First question that we will answer is why Minimal API? What is the reason behind the evolution? Does it bring any benefits as compared to the API? And what is the different structure when it comes to an API? Once we answer that basic question, we will understand the basic fundamentals of Minimal APIs, what files are there, and what is different as compared to API. Then we will be building endpoints with our API, and we will implement custom validations in Minimal API. Minimal API does not support the model state validations that are there in API, so we will see how to validate some things in Minimal API. We will learn more about dependency injection, we will inject AutoMapper, and we will see how to map DTOs in our application. And then we will perform CRUD operation with Minimal API. So you can see there's a lot that we have to cover. Let me get started with all of that from the next video. The main question that comes around all the developers, especially .NET developers, is why Minimal API? We had a perfectly functional API that has been there, and we love that with the controllers, attributes, and all the features that are built in. If that is working perfectly, why is Microsoft taking some bits and pieces out of that API and giving us a very empty template, which is something like a Minimal API? What could be the benefits of having a Minimal API? To answer that, let us consider this scenario. If a developer is coming from a non-.NET background, for example Node.js, in that case they might not be aware of what is a controller, what are naming conventions for controller, and learning all of that would require some understanding of .NET. But their main focus is to get the API up and running quickly without learning all the fundamentals of .NET programming. That is one of the reasons behind development of Minimal API. We want to have the minimal code that is needed for API rather than adding controllers. Because if you think about that, when we have to build an API, in other programming languages or even in .NET, controller is not something that is always needed. It has been there because previously we had MVC and we had controllers, so Microsoft thought about unifying both of them, and that is the idea behind controllers. With Minimal APIs, we do not have the controller. We keep everything simple and straightforward in a class file. Now when we learn Minimal API, everything will typically be in a program.cs class file, but then developers might think that my code will look ugly if I have 50 endpoints and all of them are in one file. Do not worry, we can of course separate them out in different files as well. But main point here is we don't need a controller. Now since we are not adding extra features like controllers and other overhead, which is not always needed for an API, we gain performance improvement, which takes higher priority in some situations. So if we are keeping things minimal, then the performance of our API will increase. Microsoft is investing time in Minimal API, and it is adding more and more features. Like previously, there were no filters, but they have added filters with Minimal API in .NET 7 and much more. With all the new features being added, Minimal API are gaining more and more attention, especially in scenarios like microservices, where API are not that intensive and efficiency plays a critical role. With that overview, I'm sure you are excited to learn Minimal API and what they have to offer, what is the syntax, how we can perform CRUD endpoints, and much more. To get started, we need to create a project that will use Minimal API. So I will open Visual Studio 2022 and we will hit Create a New Project. In the templates here, we will search for the regular API project and we have the ASP.NET Core Web API using C#. Let me hit the next button here and we need to give project name. Project name, I will change that to be magicvilla_coupon API. We will change the location where we want to save the project, and the solution name, I will call that Minimal API Demo. Looks good. Let me add that, and we have more options. The framework here, we will be using .NET 7. Authentication type, we will keep that as none. But later on in the course, we will be adding authentication and authorization. Configure for HTTPS looks good. We do not want the Docker support, but the main thing here is use controllers. We have to uncheck that if we want to use Minimal API. Because if you keep this checked, then it will create the regular API project with controllers. We do not want that, so we will uncheck that. And that will create a Minimal API. We will enable the Open API support. And lastly, we do not want to use the top-level statements. We can keep that as unchecked. With that in place, let me hit the Create button with the default settings. And great, our project is created here, and we have our Minimal API right here. Before we go through the files that we have in Minimal API here, let me create a regular API project. That way we can compare and see what is different. So in the solution here, we will add a new project and it will be an API project. I will call that regular API sample. Let me add that. We want to use the controller, so make sure that that is checked and we will hit the Create button. Perfect, that is created. Now that we have a Minimal API and a regular API project, let me compare to see what is different. You can see in Minimal API project, we have properties folder. Same thing is there in regular API, and there it is just the launch settings.json file that basically tells that which port it should use, and it has a profile for Kestrel as well. That stays the same because no matter if it's a Minimal API or a regular API, it still needs to run the project on a URL. Then outside of properties folder, we have app settings.json. That is also constant in both of the files. But other than that, in Minimal API, there is just one file, which is program.cs. Whereas in the regular API, we have controllers, we have program.cs, and the weather forecast model class as well. So going by the name, Minimal API has actually minimal file, only program.cs, and that file has all the logic. Now let me set the startup project as both of the project here, and let's see if the output is any different. And great, we have both of them up and running here. Let me add them side by side. And perfect, we have both of them right here. We have the regular API, and here we have the minimal API. From the look and feel, you can see both of them looks the same. We have one endpoint, weather forecast. That looks good in the Swagger documentation. We try that and execute. Everything is the same. We have the same response and everything looks the same. So from the look and feel or the functionality wise, Minimal API is not that different. Now, of course, as we proceed with the course, there will be some features that are not yet available in Minimal APIs, or they are not planned to be added, but the base functionality that we can see right out of the box looks the same. But Minimal API has only one file. The regular API has controllers, program.cs, and weather forecast. So that gives you a good comparison between the files that are present in Minimal API as compared to the regular API project. Now, as a prerequisite to this course, I hope that you have a basic CRUD functionalities of what API is responsible for. If not, I have a free course on YouTube that you can take to get familiar. But here in the regular API, we have a controller endpoint, we have the API controller, and we have the HTTP getAction method that will be the endpoint which will be invoked. And here we have this model weather forecast that is right here included. That is the regular API for you. But now let me open the only file that is present in the Minimal API, which is program.cs. Now if I switch the files here, you will notice that add controllers is not present in program.cs of the Minimal API, and that makes sense because in Minimal API, we do not have any controllers. Then the Swagger endpoints, they are present because we want the Swagger documentation with our Minimal API as well. After that, we have app.build, and that is the same. Where we are configuring the pipeline, we have Swagger documentation for development, we have HTTPS redirect, authorization, map controllers, and run. But in program.cs, we don't have much things. We have Swagger, we have the HTTPS redirect, and that's about it. We just have the app.run after that. So we do not have any authorization or map controllers that are added by default. The main idea behind Minimal API is to keep things super simple. If you have the requirement to add those, you can of course add them. Like in a Minimal API project, it is of course possible to add a regular API with controllers if you want that. But that is not the main purpose of a Minimal API. It is there to keep things super simple. So if I examine the program.cs, we just have app.run with HTTPS redirect and Swagger in the request pipeline. Now the main question is, how will it work? Before we check that, let me remove the regular API project that we added. I only added that to compare the differences so you get an idea. We don't need that anymore. With that, we only have one file here, which is program.cs open, and that looks good. Let's continue from the next video. When we run the project here, we notice that there is one endpoint, which is weather forecast. But where is this endpoint? We do not have any controllers or any other file. So basically that endpoint will be somewhere in program.cs. If you scroll down here, we have the map get right here. That endpoint is mapping a GET request, and we have the route right here. When we expand that, you can see there is a little code right here, and this defines what needs to be returned back when this endpoint is called with an HTTP GET request. We also have with name and with open API that we will come back to later on. But basically, this is how mapping is done. And if any model clauses are needed, in the default template, they are added right here. This is a record, and we have the summaries array right here. So all the calculation on what should be returned when the endpoint is invoked is right here in the program.cs class file. Now that will bring up lots of questions if you are coming from a regular API background. And do not worry, we will answer them one by one. But in order to get started, let me remove all the code that is added here for the endpoint. We want to start clean here. So perfect. Now our program.cs only has the Swagger endpoints here. Pipeline also has the Swagger UI, HTTPS redirect, and that's it. No controllers, no authorization. Nothing else is present in our project or pipeline right now. Let me run the project. We should not see the endpoint that was there before, and we see no operations defined in the spec. So we do not have any endpoints in our API, and everything is clean right now. Let's continue and add our first endpoint in the next video. The next section that I have is all about the API basics, like what is a request, what is a response, what are HTTP verbs, and so on. Now these are the fundamentals of API, and it does not matter whether it's an API, a minimal API. So if you are aware of the basic fundamentals like post, put, patch, delete, and what is a request, response with the API, feel free to skip this section and move on to the next section where we will start the programming. But if you want a refresher, let's do that from the next video. We have the big question on what is an API. The definition for an API is Application Programming Interface, but that is not explanatory. In simple words, API is responsible for transmitting the data, or rather it is a way for multiple applications to communicate with each other. In today's technology-driven world, we are connected like never before. API is the critical engine behind sharing information across multiple applications. In programming, API is responsible for getting a request from the client and then sending a response back to the client based on the request. And the request and response, there will be multiple of them, and it continues. So basically, if a client is looking for some data, it would ask API by sending a request, and then API would return back that data in form of a response. The model that we see here is the website model. What is different between that and an API? What makes an API stand out is it is not just the web browser that can call an API. Many other applications can invoke an API endpoint. So let's say you have an API that can be consumed by a web application, your mobile application, your Windows application, and much more. Not only that, you can expose your API to other clients, and we have more examples of that. But before we go into those details, the example that we see here is related to programming. Let me simplify that by going to a real-world scenario. Let's say we go to a restaurant and we have menu on the table. And after a lot of thinking, we finalize on what to order. Chef is also ready to start cooking. But the missing link here is to tell chef on what we want. That is where server comes into the picture, which is basically like an API. Server would be responsible for taking order from the table and telling chef on what needs to be prepared. And that would basically resemble a request. Once the food is ready, then server will pick that food and deliver that back to the table, which will be a response. So here you can see how server is acting like an API, where it is taking the request and then it is delivering back the response from our kitchen. Now let me show you one real-world scenario which many of you would have experienced without realizing that it is driven by API. Let's imagine we are going on a vacation and we need to book tickets and hotel reservation. Like myself, I'm sure you want the best deal out there. But it would be a huge pain to go to every airline website to see what is the price of that ticket for a specific date. Rather than that, you would prefer going to a website like kayak.com, Expedia, or Priceline, where they will display the rates for multiple airlines and you can filter the best deal from their website. What happens in the backend on kayak.com is American, United, and Spirit would have exposed an API. Kayak.com will be calling those API endpoints based on date, origin, and destination, and it will return all the response from the individual website. Whatever response it returns from those websites, it will display on kayak.com. So basically, American, United, Spirit, and other airlines would have their own API, and Kayak will be calling those API endpoints to display the connected information in one place. Same thing happens when you compare hotel rates on Expedia, Priceline, or other websites where they get information from multiple websites. So as you can see, API is the main superhero between connected services. In today's world, we take the web for granted. When we open a browser and we go to a web page, we just expect it to open up and work. That is the default behavior. But what goes under the cover is a black box. In reality, many things happen between when you search for something on the browser and what you see on the screen once you hit an enter button. Let's talk about what happens when we make such a request. We will consider an API in our scenario. For example, when we go on a laptop and search for something on google.com or any other web page, it is going to make a request to some remote server. Now this request is actually a text document. So basically it will send a text document to Google server, and this document will contain three information. First, it will have a verb which defines what is the action that server has to take. Then we have headers which have information about the request itself. And finally, we have content, which is an optional field. As an example, let's say you want to create something on the server. So in that case, the HTTP verb will be post, and we will learn about these verbs in just a minute. But when we have to create, we will be using post, and that is what we have in HTTP verb. Inside header, we might have information about the content length, that the content here will be 9 byte. And finally, we are sending magic API as the content. Let's say that is a string that we want to create. So all the data will be inside the content. Now this is just an example, but this gives you a brief idea of what will be there in the text document. When the server gets this request, it can either recognize that as something it can process, or it might reject it because something might not be valid with the request. But in both the cases, it will send a response back to the client. And in that response, we will have three items again. We will have a status code, header, and content. When client makes a request, server processes that and sends back a response. Response is also a piece of data. You can think about that as another text document. The status code here basically defines the request that was made. Was it successful? Did it fail? Based on the different failed scenarios or successful scenarios, we have different status code. In our example, we did HTTP post request, so it might send a status code of 201, which stands for created. We will get to know the status code very soon, so do not worry. Right now, it says 201 created in the response status code, which means I have created the resource that you have asked me to, and I'm going to return you some data along with that. So in content type, we are saying that the data that I'm sending back is of type text, and then in the actual content, let's say the server is sending back magic API. One important thing that you have to remember is server itself here is stateless. Stateless basically means that server will not remember things. And what I mean by that is server will be getting multiple requests. Once it processes that request and sends a response back, it forgets about that request. Because if it was remembering about all the requests, then you can just imagine on how massive the memory consumption will be, and the disk will be overloaded with the data of all the requests that it received. So always remember that server will be stateless. Based on what we have seen, we have a request that is originated from the client and we have a response. The request will have verb, header and content, and response will have status code, headers and content. In the next video, let me dive a little bit more into what exactly is in request, what is HTTP verb, headers, content, and similarly in response, what is status code, headers and content. Let me do that in the next video. Let's understand the request object that we have. First thing in the request object is verb, and these are HTTP verbs or action. They basically define what is the action that needs to happen. If you are working with some data, you might want to create, read, update or delete that data. We have specific verb which defines what action is needed for the request. Most common of the HTTP verb is when you want to fetch some resource or a web page, which basically means that, hey, get me something from the server. So get basically means fetching some data, and that is most common. After that, we have post, which is used to create or insert a new resource. Whenever you want to add a new record or anything on the server, you will be using the post request. Then we have put, which is used to update a resource that already exists on the server. Sometimes we also use patch, which basically means that please do not update the whole resource. I only want to update a part of that resource. For example, if your object has 100 properties and you only want to update one of those properties, you will use patch in that case. Put basically contains the complete resource and patch works on one part of the resource. Then we have delete, which is pretty obvious. It basically deletes the resource from the server. There are more HTTP verbs, but they are very rarely used, and typically we always play with the 5 that are most common. So that gives you a brief idea of HTTP verb and what action they are responsible for. Next part in the request object is the header. Headers are a set of name-value pair that are metadata about the request. First one you can see is the content type. That basically answers the question on what is the content type of the request. Is it a binary data? Is it a JSON file? Is it an XML file? Or is it a plain file? Then we have content length, which basically defines the size of the content. In request metadata, you might also have authorization. Sometimes request needs to be authenticated. In that case, the authorization header will be populated with a bearer token or whatever authentication you are using. We also have accept type, which defines what kind of a request is acceptable, like JSON, XML, and so on. And then there are literally hundreds of headers. You can also define your own headers if they are helpful in your situation. But headers basically have metadata of the content and request. And finally, we have content. Content is an optional field. Here we can pass the content that the server will require to complete the request. It can be a JSON object which can later be deserialized by the server to process the request. It can also be blobs that have to be created or updated. If you are trying to retrieve a resource, then you will be using HTTP GET verb, and GET will never have the body because we are requesting the API to return something, and the API does not expect any data in the request. But if you are posting or updating, then we might have to pass the object that needs to be updated or created. That way the API can extract that object from the content and process the request. This is a brief overview of the request object. That being said, let's analyze the response that we get from the API in the next video. In the last video, we saw the request object which had verb, headers, and content. Now let's examine the response object, which is basically once the request is received by the server or API, it will process that. It might be accepted, it might be rejected, failure or success, whatever it is, it will return back a response. The first thing that we have in response here is the status code. Status code is simply a number that represents on what was done on the server and its final result. But all the numbers that are returned have been arranged in some brackets, and they are very critical. Like 100 to 199 are informational. You will rarely see the 100 status code, but they do exist. Most common one that you will see is 200 to 299. Any status code in that range basically means that the request was completed successfully. 200 is most common, which says everything is okay and everything is done as requested. Then next we have 201, which means created. If you are posting something, then you can return it to someone that the resource was created on the server. That defines 201. Then we also have 204, no content. This is more common when we are updating something, because when we update a record, we just want the user or client to know that the update was successful. And we do not want to pass the updated record. In that case, we will return 204, which basically means no content. But as you can see, it is within the success bracket. That means everything was successful, but we do not have any content to return. Next bracket is 300 to 399, which are typically used when there is redirection involved. After that, we have 400 to 499, which relates to client errors. What I mean by client error means that there is an error in the request that was sent. You may not have included a query string or some part of the URI does not exist. The famous one that you would have seen on websites is 404, which represents not found. So let's say you are accessing an endpoint that does not exist. Like let's say you want to retrieve something based on an ID, but that ID does not exist. In that case, API might return back 404 that the resource that you are looking for does not exist. We have 400 status code, which stands for bad request, which means something in the request was not as expected. And then finally, we have status code within the bracket of 500 to 599, and these are for internal server error. Like the 500 here is internal server error, which means that errors have been encountered on the server while processing. So basically, the request that was sent to the server was a valid request, but when that request was being processed by a server, let's say an exception was thrown internally, and because of that, the server could not process a valid request. So that time it will send a 500, which means there was some error on the server side and nothing was wrong in the request. You can see status code plays a very important role in the response object, because based on the status code, the client will be able to know if the request was successful, if it failed, and if it failed, what was the reasons, so on. Then next we have headers in the response object as well. And they contain metadata, but this time they will have metadata about the response object, like what is the content type, what is the length of the response content, until when it will be valid, and so on. Also similar to the request object, we have content in the response object as well, and that might contain JSON result, it might contain blobs, HTML, whatever the response server has to send, that will be in content. So typically if we have to compare request and response, Both of them will have headers and content, but the main thing that differentiates them here is the verb and status code. Request has the verb, which defines what action needs to happen, and response has the status code, which defines if the request was processed successfully, if there were errors, and so on. Headers will be different for request and response, but typically headers define metadata, and content will have any content that needs to be passed with either request or response. So I hope this gives you a 10,000 feet overview about request and response and what is included in them. That being said, let's continue from the next video. Now we know the basics about HTTP verb, but let's take a look at some URL and get some theoretical idea behind the HTTP verbs. Most common HTTP verb is a GET request. Let's assume we have a table where we have a list of all the coupons in our website. That table is pretty simple. It will just have something like a coupon name, what discount we get, and some other details. But we want an API endpoint. If someone calls that, it should retrieve all the coupons and send it back. Now this is more like a read request. Because of that, the HTTP verb will be GET, and then we have the API path. Localhost 7001, whatever your domain is, that's okay. But after that, let's assume we are giving that a route of API and then coupon. We do not have any other parameter here, and this basically the action we want is to get all the coupons. So in the request body, we will not pass anything here, but in the response that we will get from the API, it will give us a list of all the coupons from our database. So that is a GET request. Now another type of GET request is where we are passing an ID of the coupon. At that point, the HTTP verb is still GET. But because there is an ID here, we know that the user only wants one coupon. Request will not have any body, but the response body will have the single coupon that user wanted. Now of course, if the ID is invalid, we will not send any response body with the coupon. But if that is valid, the response body will have a coupon. These two are basic requests in HTTP GET. But let's say if a user or admin wants to create a new coupon code. In that case, our HTTP verb for the request will be POST, and we will use the same URL. Now the way it will differentiate between the first URL and this one is the HTTP verb will be different. If the verb is POST, the API will know that that means that we will be creating a coupon. So API automatically differentiates between the verb even if the URL are same. So for POST, we will create a coupon, and when we are creating a coupon, if someone sends a request, we obviously need the details about that coupon. Like on the website, someone will write the coupon name, what is the discount they want, and then the admin will hit the create button. At that point in the request, we will get all the coupon details that the API has to create. So API will create that coupon when it receives the request, and in the response, it could send the created coupon or a route to that created coupon. Now, if everything here does not make sense right now, do not worry. I am just giving you a basic idea of API and its action. Next action or HTTP verb that we have is put, and that is to update any existing coupon. In the route here, when we are updating, we can pass the ID of the coupon that we want to update. Because of the HTTP put verb, in request we will require the coupon details that have to be updated. And once the API updates the coupon, it typically does not send any response like the updated coupon. If you want, however, you can send it, but that is not the typical route that is taken. And finally, we have the delete HTTP verb, where again we will pass the ID here. Action, we just need to delete that coupon. It does not have any request body. or a response. Based on the ID that is there in the parameter, it will delete that coupon and return an OK request. That means everything was completed successfully. So what we have seen here is what will be in the request body or what we will get in response based on the HTTP verb and something in the URL, whether we require an ID, if we don't need it, and so on. So this should give you a brief idea about what each request or rather HTTP verb is responsible for. Now again, this is just a rough idea. Once we start programming, everything will start making much more sense. That being said, let me continue from the next video. Let me add our first endpoint right here. One thing that you should remember is all the endpoints, we will have to configure that before the pipeline ends. Because in a traditional API project, if you remember, we were using something like app.addController, and that was adding controller to the pipeline. Here we are not adding the controller, so all the endpoints of your API that you want to add, you will have to add that before app.run. Right here, we will say app.map, and you saw before we had something called as map_get. That actually maps or rather tells that this will be an HTTP GET action method. If you examine the parameters here, we have string with a pattern and a delegate handler. Pattern defines the route of this API. So we can say something called as hello world, and what should that return? You can keep it simple and we can just return back hello world like that. That will add an endpoint in our Minimal API. Let me run the project. Perfect. You can see we have that route here. We can try that out, execute that, and we have hello world. If you want to test that using Swagger or it is an HTTP GET, we can directly paste that and we see hello world right here. Perfect. You can see our endpoint is working as expected and how simple it was to add an HTTP GET endpoint right here. Now that would make you curious and now you will be like, can I have an HTTP post endpoint? Of course you can. We just have map post here. We can call this hello world 2 and we can return hello world 2. Now typically in HTTP GET, you will have something in from body where you will be creating a record, but we are keeping things super simple right now. Let me run this and see if that works. Perfect, we have the post here. Try that out. We don't need any parameters. And perfect, we get the response. That looks great. If it was an API project, there is no way that you can add one line and the endpoint will be added there. But here, it is pretty simple. Similar to map_get, we have map_put and map_delete. So that way, if we add app.map here and we scroll down, we have the delete, we have the patch, post, put, and where is the get? Right here. So you can see we have all of those basic methods for the API endpoint. With that in place, let me continue from the next video. Right now we are adding or returning what we have in a single line. But what if you have a complex calculation that your API needs to handle and you need multiple lines for that? That is simple as well. We will remove this and we will add a curly bracket here. We can perform all the calculations right here. But to keep things simple, we will just return hello world right now. Perfect. This will work exactly the same. Let me run that and show that. Try that out. Perfect. That looks good. Now right now you can see it returns a 200 OK. That is the response that we are getting from the server. But let's say there are some errors here and we are returning an exception here. But that time also it will return a 200 OK. Right now, there is no way to tell that, hey, this is a bad request or something went wrong on the server. So basically, we have no way of controlling what is the return type for our API right now. That is also done. Everything that we want to return inside results dot, and we have the endpoints for the status code. We have accepted, created, not found, bad request, and all of that right here. Let's say we have a bad request here, and inside there we are saying that there is some exception that is being thrown. Let me run that. We will try this here. And perfect. Now you can see our API is returning a 400, which stands for bad request. If everything was good, right here we can directly return results.ok. Inside there we will pass the hello world if we want to keep that in same line. If you want multiple line, you can add the curly brackets and do the same thing with results.ok. Let me run this and make sure that works. We are in post here. Examine the response. That is 200 OK. So perfect. With that, let's continue from the next video. The return results here, we can toggle on whether it is a good request or bad request. But in an API endpoint, sometimes we have to pass something to the parameters. That might be a from body, or let's say an integer or a string parameter to parse some data. When we have to use an integer, typically in an API, we have to write the integer name here. Let that be an ID. That stays the same. But right here, we will say that we are expecting an integer ID, and we don't want exception. We will say OK here, and we can print the ID. And we'll just say plus here. Let me run that. Perfect. You can see it expects an ID. Swagger UI is displaying that. Let me enter 11 and execute. Perfect. We have the correct response. If you enter a string here, Swagger will display the error message. It has to be an integer, but we can open Postman here, paste that URL, and see what happens. We see the exception here, failed to bind the parameter integer ID from this. And you can see the response type is 400 bad request. But if we are passing a string, then this should actually be a 404 not found, because the get endpoint that we have is the endpoint with an integer and not a string. How do we fix that? Fixing that is super simple. Let me go back to the map get here. If we go back here and we explicitly say that this ID will be an integer only, that should solve our problem. Let me go back to the Postman and let me execute. And perfect. This time we have the 404 not found, and that looks good. So we can be explicit with the parameters similar to what we had in the API project as well. We have seen some basic examples of adding the endpoints, but let me work on something that is close to a real-world application. Let's say we want to perform CRUD operations on a model, and that will be coupons. So first we need to create a model for that. Inside solution, we will create a new folder, and that will be models. In there, we will right click, add a class file. I will call that as coupon. And inside there, I will create 6 properties. We will have ID of the coupon. We will have the coupon name. What percentage discount will that coupon give? And if that coupon is active or not. I will also add a nullable created and last updated. Now, if you are new to .NET 6, and if we examine the project here, edit project file, you can see null label is enabled by default. This basically means that if something is null, you have to explicitly define that property will be null. But to make things simple, or if you are working with a legacy .NET application or .NET Core project that is an older version, this must be disabled even if you upgrade that. Because many times, personally, I have seen when I have upgraded the project to latest versions of .NET Core, and if this nullable is enabled, API endpoints are breaking. Because previously we did not explicitly define every endpoint that it is a nullable endpoint, but now if that is not defined, it does not find that endpoint. So to be safe, you can disable the nullable in the CS_proj file. But right here we have explicitly said that created and last updated is nullable, so we should be good. But to avoid any issues or confusion, we have disabled the nullable flag inside the project file. So our class here looks good. Next, we need to create a store that will have a list of coupon. Now down the road, or typically in a real world project, you don't have a store, you have a database where you manage or update all the coupons. But to keep things simple for now, we will add a coupon store. Let me create a new folder, which will be data folder. And in there, we will add a class, which will be coupon store. Inside there, we will add a static property, which will be coupon list. That will be list of coupon. And we have just added 2 coupons in there. We will make this a static class as well. That way, we do not have to create object every time. Perfect. So our coupon store can now be accessed with our new API endpoints that we will create in the next video. Now that we have coupon store and coupon model, it is time to add the first endpoint that will retrieve all the coupon. So we will say app.map_get_endpoint, and the route here, rather than calling it coupon, I typically like to add API in front of that. So we will say /API and then coupon. That will retrieve all the coupons. We will be using the delegate here, and what it should return is results.ok. And inside there, we have to access the coupon store that we created. I will add the using statement, and in there, we have the coupon list. That is what we need to return. With that in place, let me run the project. Perfect. Let me try this out here. And great. We can see both the coupons in our coupon store. Now right now, even though we have one line here, let me add a curly bracket here and break this out. Right here, we will add a return statement, and we are missing the closing semicolon. Perfect. We have the multi-line function right here. Great. So our get endpoint looks good. Let me continue from the next video. We have the endpoint to get all the coupons. But what about when we have to retrieve an individual coupon based on the ID? We can create that as well. We know how to retrieve the ID. So right here, we will expect an ID, and that will be integer. We will have the same name here, integer ID. And then when we are returning back the result here from the coupon list, we can use first.default to retrieve the record based on the ID. So u.id is equal to the ID. Perfect. Let me run the project. We have ID1 and ID2. Let me try the ID2 here. And great, we get the 20 off. So our coupon store is working as expected. We have 2 IDs, and that retrieval is working. Next, what we want is post, put, and delete action endpoints. So let me just add them for now. We need the post here to create a coupon. And when we post, we will use the same path API /coupon. Now, of course, when we post in the handler here, we will receive a different object, but we will worry about that later on. Let me copy this and paste it 2 more times here. Like map post, we have map put here, and we have the map delete. Now in post and put, both of them we will receive the coupon object in the parameters. That way we can create or edit the coupon. But when we delete here, we will receive ID. So let me copy that, and we will get the ID right here. Perfect. So these three looks good. In the next video, let me first work on creating a coupon. Now we want to create a coupon. When we create a coupon, we typically receive a coupon object from the body. So getting that is exactly same like we do in API project. We will say from body in the parameter here, and we will receive a coupon object. Let me call that coupon, and we will add using statement for our model. Now from body requires a using statement which is in Microsoft.ASP.NET Core.MVC. But once we add that, it will know that a coupon object will be passed from body when the post request will be called. Then before we create, we typically have some validation. We will add a validation here that if the coupon ID is not 0 or if the coupon name is empty, that is an invalid ID or coupon name. Because when we are creating, the coupon ID must be 0. If it is something else, then that is not a valid ID, because ID is something that typically the database or the code is responsible for adding. But we don't have any database right now, so now we need to populate the ID. How will we do that? We will keep things manual. We will say coupon.id is equal to, inside our coupon store, we have the list. There, let me order by descending. So we will get the maximum ID at the top here. U goes to u.id. And on there, we will retrieve the first record. There, we will retrieve the ID of that record. So here we are getting the maximum ID of all the records that we have in our coupon store. So that will be 2 right here. On that 2, we will add 1. That means that we are manually setting the ID plus 1 by the maximum ID in our coupon store. And before I add the ID here, I want one more validation. I do not want the same coupon to be created again. So we can add an if condition in our coupon store and try to retrieve first or default based on the name that is being created in the coupon. I will use the 2 lowercase. That way we will make coupon case insensitive. So if the code already exists, we return bad result. Coupon name already exists. Pretty good. Next we have the ID here, and then we have to add it to our coupon store. .couponlist.add. We will be adding coupon. Perfect. Our create or post is complete here. Once we do that, we can return back results.ok, and there we can return coupon that has been created. Perfect. Let me run and see this in action. Only parameter that we have to change here is name. Let me call that 30 off, and it is a 30% discount. ID, we can leave that as 0, because if we go back to our application, we are changing that ID based on the ID that we have in our coupon store. The maximum one is 2, so next one will have the ID of 3. The ID here, we can remove that and it will still work because it will automatically populate the ID. Let me remove that and hit the execute button. We scroll down and perfect. In the response body, you can see ID is 3. If we go back and we try to get all here, now we have 3 coupons. But again, this is a temporary data store. When you restart the application, your coupon store will be back to the first 2, which are the defaults that we have. So keep that in mind. We are not storing this in database. it is temporary and in memory. So perfect, our post is working as expected. Let me continue from the next video. Before I work on put or delete, when we have the post here, there are quite a few things that are missing in our API endpoint that we typically do in a .NET Core API. One thing is, rather than returning an OK in HTTP post, sometimes we return the created at route. Now, of course, we can return the created, and that is completely okay. Before that, let me show you how to use the results.created. When we use created, we have to write the route where this is created, and then for the value, we can pass coupon. So the URL here, let me use string interpolation here. It's API/coupon, and there we need the ID. ID will be inside coupon.id, and let me run that. We will create a new coupon. We will update the name and %, and let's go down. That is created here. We have 201, and in the location we have API, coupon, and 3. Let me go to the localhost URL here. We will add localhost, and then we will paste the route that we copied. And great, that retrieves the appropriate coupon with the correct name and %. So created is working as expected. But what if we want to use the created at route? For that, we actually have to give this get some route name. How to do that? With Minimal API, after the map get here, we have something called as with name, and there we can provide name of this endpoint. So right here, I can call this endpoint as get coupon, and then we can use that name. The first one here, let me call that as get coupons. The HTTP post, we will call that as create coupon. Then rather than using created, let me copy this, comment it out, and we will be using created at route. Inside there, we need the route name as the first parameter. That is get coupon. Next parameter here is the ID. So we will create a new object, and we will say ID is equal to coupon.id. And finally, we will pass the object. That looks good. Let me see if that works. We will post again. It will create an ID 3. Let me try that. And perfect, that looks good here. In the location, we have the complete URL as well as the endpoint. If you copy that and try that, it should work. Perfect. So with that, we know how to use the with name to give our endpoints a name, and then we can use that in something like created at route. Now we have the names for our endpoint, but if I run the project here, and if I look at the Swagger documentation for HTTP post here, the response type here, it says that it will only return a 200 OK. But that is not correct. If we go back here, if the ID is not 0, let me try that here. So we will keep ID as 3, execute this. We get a 400. So basically our endpoint can return a 400 bad request. But in the available responses in the Swagger UI, it only thinks that it will return a 200 OK. And that is because in a traditional API application, we have the HTTP response and we explicitly say that these are the possible status code that our endpoint can return. How can we define that with Minimal API? For that, on the map post here, where we have the with name, we also have something called as produces. And here we have generic, where we can say the model that will be produced. We know we are creating a coupon here, so I can say produces a coupon, And then what will be the status code? If everything is successful, that will be 201. We also have a bad request here, so we will add produces. And when it is a bad request, we do not have any model, so we will just add a produces 400 bad request. If you have other status code, you can also add them right here. Let me copy this, and we will modify our individual get and get all. Now this one will produce a 200 OK. It does not produce bad request. So let me remove that. And 200. The first one here will not be a coupon. It will be an IEnumerable of coupon. Perfect. Let me restart the application. Right here, you can see we have an array. When we have the individual get, we do not have the square bracket. But let me open the post here, and there we have 201, we have the correct model, and 400 bad request, we do not have any model in that. So that way we can explicitly define what will be the response that will be produced. On top of that, you can be explicit on what this endpoint will accept. Right here, it is expecting a coupon, so where we have the with name, we can also say dot accepts that expects a coupon, and there you can explicitly write the content type. Like if you want to limit application JSON, you can say that explicitly right here. With that, let me run the project once again. We go to post here, and everything stays the same because we had the request body, but that is more documented, and now the Swagger can read what are the exact things that it expects, what it produces, and the models as well. So perfect. With that, our 3 endpoints that we have, I believe we have good documentation so far. Let me continue from the next video. When you work with a .NET Core application, dependency injection is a very critical piece, and Minimal API supports that. So don't panic. The first example that we will see is the built-in iLogger that comes with an API project. To see that in action, let me create an API project because I removed the one that we have here. We will create a sample. That's okay, we don't care about anything else here. And perfect. Here, if we open our controller, you will notice we have an iLogger. On there we can use to log something in the console window. This iLogger is being used with dependency injection, and it is available by default. So how can we use that in our Minimal API project? Let me log something when we are getting all the coupons right here. In the parameter here, we can explicitly say that we need an iLogger. So if I go back to the API project, let me copy what we were passing in the constructor here. We do not need to create a private read-only. We can directly retrieve that in parameter like that. You can see iLogger is being detected, but it does not detect the weather forecast controller. But right now we are in program class here, so we can say that right here. And with that, the logger has been injected. I like to use underscore for all the dependency injection that we have. We will add underscore logger. On there we have the log method. Log level, we will say information, and we will say getting all coupons. Let me run the application and see if that works. We are using Kestrel to run the application, so when you run the project, you will actually have a command line window like this that is open. Make sure to open that. If you do not have that, and if you are using IIS Express to run that, you can also go to the output window, and we have debug here. Let me pin that as well. Perfect. Now if I go back here, let me try to get the coupons. We execute that, and perfect. You can see in the logs here in both the places, in the console window if that is open, If not, we have the output window here. We have the log, which is getting all coupons. So that way you can see how dependency injection is already built in with minimal APIs. If you are injecting something that is not available, you will of course have to inject that where we have the add services right here, and it will basically be before line 14 where you are calling the builder.build. So where we have the builder.services, you can register new services, and in the endpoint, you can directly get the implementation. So with that basic example of dependency injection, let's continue from the next video. Now let me run the project here, and I want to show you when we are posting here, we do not want all of these properties. We only want name, %, and is active. So in a typical API, we do not expose the complete object. We only expose the DTOs for that endpoint. So for create, we will add a DTO in our project. In models folder, let me add a new folder for DTO. And in there, I will add a new class, which will be coupon create DTO. Now there, I only want 3 properties. So let me copy them and I will paste those right here. We will go to our endpoint here, and when we are creating from body, we will only retrieve the coupon create DTO. That way we are only getting what we want. And I will call this coupon underscore C underscore DTO, which is coupon create DTO. Let me change the names here. We need the ID as well. Now in our coupon create DTO, we do not have the ID. We can remove this condition, but where we have to assign the ID, we actually have to convert this coupon create DTO to coupon DTO. So if you want, you can manually do that. Coupon is equal to new, and we can do the manual mapping like that. Once we do that, we can add ID on this coupon, add that to our coupon store, and we are returning back the coupon. Now, rather than coupon here, let me add a new DTO that we will call that as coupon DTO. The reason behind that is, let's say we never want to show when the coupon was last updated. So in the coupon DTO, we will not have that property, and we will return back the coupon DTO. So produces here will be a coupon DTO, except we will change that to coupon create DTO. And when we return back, we will basically have to convert this coupon to the coupon DTO. So right here, we will need the conversion again, like that. And perfect, that looks good. We will return back the coupon DTO. Let me run the project and see that in action. We go to our post here. Perfect. Now this is different. We only need few properties here. Let me change those. And we execute. We take a look at the response. Perfect. Updated is not present, and that looks good. Now created is null. You can change that if you want, but I will skip that for now. Basically, our DTOs are functional, and we are not exposing our entity, which is coupon. That is great news. But having all this conversion is super ugly. I would love if someone will already do that for me. And the answer for that is in next video. Mapping all of the object manually is super painful. Thankfully, there is AutoMapper. So for that, we will have to install the NuGet package. Let me go there. In the Browse tab, we will search for AutoMapper. We will have to install the default AutoMapper package, and we want to inject AutoMapper with dependency injection. So we will install automapper.extensions.microsoft.dependency injection. Perfect. Both of them are installed. Now, how can we define the mapping? AutoMapper is smart. If the property names are same here, it automatically maps them. But we need to tell AutoMapper that, hey, you should be mapping coupon to coupon create DTO or coupon DTO to coupon. That is something that we have to tell AutoMapper. Let me add a class file and we will write that inside that class file. I will call that as mapping config. Now, if you want that configuration, you can do that in program.cs when we register that to the container. But rather than keeping everything clustered in program.cs, I like to separate it out. Now that mapping is present inside the profile that is inside AutoMapper. Once we add that here on the class file, in the constructor, we can call the default methods, that is createMap. That createMap is inside the profile, and there we have to tell the source and destination. We want to map our coupon, we will add the using statement, and we want to map that to coupon create DTO. Now that will only map coupon to coupon create DTO. But what if you want to map coupon create DTO to coupons? That is simple. We just have reverse map that, and that will handle both the scenario. I will copy this. Next, I also want coupon to coupon DTO. We will not be mapping coupon create DTO to coupon DTO, so that mapping is not needed. Perfect. These two mapping look good. Now we need to inject AutoMapper to dependency injection. And that we will have to do before we build the application. So right here, I will say builder.services.add AutoMapper, and there we will explicitly say type of mapping config. Mapping config has all the profiles for our AutoMapper that we need. And with that, it will do all the magic of dependency injection, and we can use that right here in our post endpoint. If you remember, when we have to inject the logger here, we were using iLogger. Similarly, we want the iMapper. Let me call that _mapper. And we need to add the using statement for AutoMapper. That will automatically inject the mapper based on the mapping profile that we have. When we have to convert something, we will say coupon is equal to and _mapper.map. We want to map this to a coupon, and here we will say we want to map this coupon create DTO, and this will be the destination. So it will automatically map this coupon create DTO to coupon and assign it right here. One line to replace all the mapping. Pretty simple. Let me go back, and here we will say _mapper.map. What is the destination? That is coupon DTO. Let's add that. And what is something that we are converting, or the source here? That is coupon object. Nothing else is needed. Perfect. That looks good. With that, let me run the project and make sure it still works. We will try to create something here. And great, that is still functional and everything is working as expected. If you have worked with the APIs with .NET, you know that where we have all the models, like right here we have the coupon create DTO, we can add something like required, and we can add data annotation. Then if we go to program.cs, right here on the request we can check if the model state is valid, then proceed further. But with minimal APIs, model state validators are not included by default. Well, at least not for now. It might be in future, but that is not there in the roadmap. And the idea is to keep it minimal, so if you require validation, you can of course add your custom validation. Like right here, we have the bad request and so on. But if you want to use something else like Fluent API, you can also add that in your API project. In order to add that, we will be adding NuGet package. So right here, we will search for Fluent Validation. We will be installing the Fluent Validation.dependency injection extension. Perfect, that looks good. And with that, we can add validations. Rather than clustering everything, I will be adding a new folder here. Call that as validation. And we will be adding individual validation. Now validations might be different when you are creating or when you are updating a coupon. So let me add a class here which will be coupon create validation. For Fluent validations, we will have the base class of abstract validator. We will add the using statement, and there it is on generic. So we need to define what this class will be validating, and that will be coupon create DTO. We can add the validation in constructor here, and with Fluent validation, we use rule for, and there we define what is the validation we want. So first thing, we do not want name to be empty, and the percent, it must be between 1 and 100%. That is straightforward. How can we add that validation inside our endpoint right here? Well, we need to inject the validator right here, similar to what we did with AutoMapper. So right here, let me add iValidator on coupon create DTO. We will call that as underscore validation. And before we check for the name here, we will say variable validation result is equal to async, and on the underscore validation, we have validate async. Inside there, we have to pass the coupon create DTO. Now we have an error here because this is an async method and we will have to await. But the endpoint that we have here is not async. One workaround is to remove await, and right here we can call the getAwaiter.getResult, and that will work. That is completely okay. Let me show that. Once we have the validation result here, we can check if the validation result dot we have the is valid. If that is not valid, we will return back an error message. Now error messages are also inside the validation result here. So we can say validation result dot errors dot first dot default, and we can convert that to a string if there are any errors. So that looks good. Of course, if you want, you can customize that. Rather than returning first dot default, you can return all the errors. But again, we are keeping things super simple. Perfect. Let me run this and show the error message. When we run that, we see a weird error message. Failure to infer one or more parameters. And in the parameter source, we have something called as unknown. Well, here it says, did you mean to register unknown parameter as a service? That basically means the dependency injection that we added for validation here. We of course forgot to add that to our container. So to add that, we will say builder.services.addValidator from assembly containing, and here the class that we are in is program class. That will register the validator service, and we can use that with dependency injection. If we run that, everything works, and let me try post here. Percent, we will make it more than 100, and execute. We scroll down. Perfect. We see the error message, percent must be between 1 and 100. You entered 1110. So our validation is working. But if we go down here, we are using the getAwaiter.getResult. Let me continue and remove that in the next video. Now we are using the getAwaiter.getResult. But what if we do not want that? We indeed want to await here, and we want to make our endpoint async. Doing that is no big deal. Right before the bracket here, we can write async here, and that will make our endpoint an asynchronous endpoint. So that was a super easy fix there. But now I have one question for you. We are injecting two things here, AutoMapper, iValidator, and then this one we are retrieving from body. If we go up where we have the integer ID, even if we don't define anything here, let's say if we are saying that iLogger will be present here, and then we have the integer ID, if we run that, you will notice it works. Try that out, and great, that works. So how is the application determining on what it is getting with dependency injection, what it is getting with parameters, and everything is confusing because we are not saying that this iLogger is actually being injected. What happens is the application will first see for all the parameters that, hey, is there a dependency injection registered for this iLogger or AutoMapper? If it is, then I will be injecting that right here. For the other parameters like ID, it knows that it is expecting an ID here, but if it is a coupon create DTO or something else, and it does not find any dependency for that, then it knows that that will be provided as parameter. It does all of those pretty smart mapping automatically, and we do not have to worry about that. So that is one thing that I wanted to point out. With that, let's continue from the next video. Now with the endpoints that we have, like let's say we have this coupon create DTO right here, we are returning back a coupon DTO. And then when we have get here, we are returning a coupon. For get all, we are returning an IEnumerable of coupon. What I want to do is rather than returning a different response based on the type, I want just one single response type, and that will of course have a data. Along with that, it will have other properties like any error message, whether the request was successful, what was the status code, and so on. So that way all of our endpoint will have a standard response message. So in solution here, in our models, let me add a new class. I will call that API response. In there, I want few properties. First one will be a boolean on if everything was good. So that will be is success. Then we want an object, which we will call as result, and anything that our API or endpoint returns back, like a coupon list or a single coupon, or the coupon that was created, all of that will be in this result object. Next, I want the status code, so that will be of type HTTP status code. And finally, I want all the error message. So list of string, and we can call that as error messages. Perfect. That object looks good here in the constructor. We will just say error messages is equal to new list of string. Perfect. Looks good. So rather than returning anything else here, every time we will be returning the API response. So at the top here, we will have a new API response, and where we are returning, we need to store the result in response.result is equal to, we have the coupon store.coupon list here. And once we retrieve that, we can say response.isSuccess is true, and response.status code is equal to http status code.ok. Let me remove system.net here and add that in a using statement. Finally, when we have result.ok, we can return back the response. That looks good. This way we are standardizing what will be the return type. That will be API response. Let me copy these 4 lines, and we have the map get here. Let me work on that. We also need the API response. I should have copied that. And the result here is right here with first.default. We will paste that. And perfect. That looks good for the get individual coupon. Then let me copy this again. Where we have the post, I will paste it right here. And when we are actually creating, we can just set the isSuccess to be false and the status code to be http status code.bad request. That way, where we have the bad request, we do not have to assign both the flags here. Let me cut the result here. Everything that is good will be at the end. We will paste it right there. But when something is not valid, we need to assign the error message. So we can say response dot we have the error messages dot add. We will be adding the error message right here. Cut that, paste it, looks good. Again, you can be fancy. Rather than first or default, you can return all the error message, but you will have to do some conversion. Where we have result.bad request, we will return back the response. Let me copy these two lines. We will have to add that right here. And perfect. Looks good. Now here, rather than using Fluent validation, sometimes you also need server-side validation. That is why I have added the custom error message and returned back the response. We go down here, where we have the created at route. We will return just OK here because we have a standard response. That response will have the coupon DTO, so let me add that here. And the status code here, you can of course say created if you want, and that looks good. We do not need this return statement. We will comment, and let me cut and paste it at the end where we have the other created. With that, the accepts here looks good, but the produces is API response. 201 looks good. Let me make sure everywhere we have that. It will be API response. Great. We have modified quite a few things, but now we have streamlined on what will be the response. For all the endpoint, it will only have our standard API response that you can see. Let me try the get here. And isSuccess is true. It returns them. Status code 200. Looks much better. Let me try the post here. We will try an invalid %. And perfect. We have the error message. Everything is much more organized with a single type of API response. Let me try to create and make sure that works. Make this a valid one. And we scroll down. Perfect. isSuccess. We have the result. That looks good. With that API response, let me continue from the next video. Now that we have added the get endpoint, get all, and post, I want you to take an assignment and implement the put and the delete endpoints. One thing that you have to be careful is with the put request. If I go back, for create we have a coupon create DTO. There we don't have an ID. But when you are updating, you will require the ID that needs to be updated. So for that, you will have to create a new DTO, call that coupon update DTO, and implement all of those endpoints that are missing. We already added them. You just need to implement these two endpoints right here. So good luck with that assignment, and I will show you the solution in the next video. I hope you were able to complete the assignment. First thing, we need to create a DTO. We will copy and paste that, and this will be coupon update DTO. The name here, one property that I want to add here is the ID. Everything else looks good. Perfect. We need to work on map put here. Let me go to the map post and copy what we have. Paste it right here. Route is the same. We will change that to be map put here. And we need AutoMapper, validator. will be on coupon update DTO. And from body, we will receive a coupon update DTO. Perfect. Now that we have validation, let me add that as well. Copy and paste here. And we have coupon update DTO. Let's add that. Perfect. Now when we are updating, we can add one more validation that ID cannot be empty and it has to be greater than 0. Perfect. Validation looks good. Let me go back to where we have the HTTP post. Let me copy what we have here and we will update. Perfect. Copy that. Let me add some space here. That way I can easily read that. I think this is good enough. Delete, leave some space. Perfect. Let's see what we are doing here. We have the API response looks good. We are validating. Let me call this _u for update. Perfect. We are validating the result here. That looks good. Let me scroll down. We have the logic for if coupon already exists. We will have to tweak that when we are updating to make sure we don't get the ID that we are already updating. But I will skip that for now. You can add some more validations here if you want, but I will keep things super simple. After that, in order to update, we need to retrieve that coupon. So basically, we will retrieve that coupon using first or default based on the ID that we receive in the coupon_u.dto. Once we retrieve that, then we can manually update all the properties in this coupon that we retrieved from the coupon store based on the coupon UDTO that we receive in parameter. We do not need any of these logic here. Let me use AutoMapper. Using AutoMapper, we will map that to be coupon DTO, and we want to convert the coupon from store to coupon DTO. Assign that to the result. Status code here will be OK and not created. And perfect, that looks good. We also need to add the accepts here. We can give that a name, so let me copy this. And right here, I will paste that. Name, we can call that as update coupon. It accepts a coupon update DTO. And produces will be 200 OK. Great. Our update looks good. Let me run and test that. If we try to get here, we have 1 and 2. Let me try to update 2 right there. Not post, put, try that. ID, if we keep that as 0, we should see our validation. Perfect, ID must not be empty. We will keep that as 2 here. Change the name and % here to be 12. Let me execute. We scroll down. Perfect, it is successful. Let me try the get all here. And great, our update is working as expected. Let me go back and we will update the delete. I will copy what I have within the method here. Paste it inside delete. We only receive the ID here. You can add a custom validator for delete, but we will keep things simple. And I will remove the validations right here. When we are deleting, we want to retrieve that. So we will retrieve that using first.default. And here we can just check if coupon is not null, then we will delete. And this will be coupon from store. In that case, we will remove the coupon from coupon store. Else we have an error here, so we can add the error message invalid ID. Default success is false, so we can return back the response. Perfect, looks good. If everything is good in the if condition here, we can return back the success is true and status code is okay. If you want, you can also return no content. It depends on how you want to implement, but with delete, typically we return no content. Perfect. Looks good. With that, let me try delete in action. We get here, we have the default 1 and 2. If we try to delete the ID 3, we should get error message invalid ID. Let me try 2 here. We get 200 OK. And execute that. Our store now only has 1 coupon. So perfect. With that, update and delete functionalities are working as expected.